It's a big surprise. Nobody thought the ocean was this deep. So all of a sudden we've got scientists saying, why is that?
The deeper the descent, the more unimaginable the pressure becomes. At a depth of 11,034 meters, at the Challenger Deep itself, the weight of the water is 50 times greater than the pressure inside a rifle barrel.
Conditions are so extreme that even the cells that make up all living things would be destroyed.
This region is known as the Hadal Zone. When scientists deploy human-made exploration vehicles into these depths, the data they bring back begins to reveal phenomena that modern science cannot explain. Layer by layer, we are peeling back the limits of our understanding and confronting the unsettling events recorded in the deepest part of the ocean. Hadal, the Hadal Zone, Earth's final frontier. The Hadal Zone, located within the Challenger Deep, is the deepest region of the ocean. It begins around 6,000 meters below sea level and descends to 11,034 meters, the greatest depth humans have ever measured. These numbers are not meant to impress on their own. They mark a place where the natural environment changes so drastically that it no longer resembles anything familiar on the surface. At this depth, the pressure surpasses 16,000 psi, more than 1,000 times what we experience on land. Such force can bend metal, damage equipment, and make ordinary materials behave in ways that seem impossible. The temperature remains between 1 and 4 degrees Celsius, and sunlight never reaches this far. It is a place where cold, darkness, and relentless pressure combine all at once. For many years, scientists assumed the Hadal Zone was almost empty, yet every expedition sent down has overturned that belief. Even determining the exact depth of the Challenger Deep has been a challenge. Early measurements from the HMS Challenger recorded depths above 8,000 meters, while modern instruments suggest nearly 11,000. The discrepancy comes from how water compresses under high pressure, changing the speed of sound and confusing depth calculations. This alone shows that the Hadal environment is not simply different, but far more unpredictable than expected. The pressure here affects more than just measurements. Materials engineered by humans, including steel, ceramics, and titanium, are pushed to their absolute limits. Any flaw, even a minor one, can cause cracking, deformation, or catastrophic failure. Several submersibles have fractured or collapsed at depth. These failures reveal that the Hadal Zone acts as a natural stress test for modern technology, a place where nothing is forgiven. Here, seawater becomes denser, the seafloor reacts to force in unusual ways, and small changes in the environment can create effects that do not match surface-level models. Equipment brought back from these depths often records strange pressure fluctuations, brief flashes of temperature changes, unexplained sounds, and light vibrations that feel like movement beneath the sediment. Not all of these signals come from living creatures. Some may be caused by shifting sediment or pulses of energy rising from the earth below. But the key point remains: the data does not follow the same patterns scientists are familiar with from other parts of the ocean. It leads to an important conclusion. The Hadal Zone is not only deeper, colder, and darker. It is a place where the usual rules of nature begin to lose their reliability, forcing science to reconsider ideas once thought certain. This is why the Hadal Zone is often called Earth's final frontier, a realm where biology, geology, and technology are pushed to their breaking point. Life that should not exist, yet does. For decades, scientists believed that at such extreme depths, where pressure can crush steel and darkness is absolute, life simply could not survive. Yet every expedition into the Hadal Zone has overturned that expectation. In 1960, the bathyscaphe Trieste reached the bottom of the Mariana Trench. Inside the vessel, Don Walsh and Jacques Picard reported seeing a flatfish-like creature moving across the seabed. At the time, this observation went against everything science believed because no fish was thought capable of surviving such pressure. But that single sighting opened a new question. If one large creature can exist down there, what else might be hidden in the dark? Decades later, in 1995, Japan's Kaiko probe expanded the record of life found in the Hadal Zone. It discovered massive single-celled organisms, some up to 10 centimeters long, roughly the size of a human hand. These oversized cells showed that life in the Hadal zone had evolved in ways never seen elsewhere on Earth. The deepest living fish known today, the Unimaginable, the Mariana snailfish, survives at depths reaching about 8,100 meters. This is a place where the pressure could crush human bones instantly, yet the small, fragile-looking fish continues to function normally. Its secret lies in its biology. Its body is adapted to resist extreme pressure, its proteins are stabilized by special molecules, and every part of its structure is designed to withstand a world that should be lethal. Scientists once believed this depth marked the absolute physical limit for any bony fish, but data from deep-sea missions shows that below 8,100 meters, there are still traces of movement and disturbances that do not match any known creature. Long trails carved into soft sediment, fast-moving signals on sonar, and unusual disruptions that shallow water animals could not create. These findings raise a troubling question. If the species we can observe represent only the beginning, what is living below the supposed limits of life? The remarkable thing is how these organisms survive. They are not breaking biological rules. They follow a different set of rules entirely. In a world where pressure destroys ordinary structures, these creatures adapt by becoming softer, slowing down their metabolism, stabilizing their proteins, and withstanding extreme cold far better than shallow water species. Their existence is clear evidence that the Hadal zone is not just the deepest part of the ocean, but a testing ground for life on Earth, a place where familiar limits begin to fail. And if tiny snailfish and giant single-celled organisms can thrive here, the unexplained traces found deeper down pose an even larger question. Is life in the Hadal zone evolving along a path science has yet to imagine? Marks bigger than any known creature. During expeditions into the Hadal zone, one set of data has confused scientists more than anything else. On the soft sediment at the bottom of deep trenches, cameras have captured enormous tracks that should not exist. These are not small scratches or natural ripples. Some of the marks are nearly 1 meter wide and stretch for hundreds of meters, as if something heavy and solid had slid across the seafloor and carved a path into the mud. The problem is that every creature known to survive at these depths is far too small to leave anything like this. The so-called giant deep-sea amphipod, Alachella gigantea, though much larger than its shallow water relatives, reaches only about 30 centimeters in length. Giant single-celled organisms known as xenophyophores, despite their size, are soft, fragile, and roughly the size of a human hand. Neither has the weight, structure, or strength needed to carve deep trenches into the seabed. Yet, the tracks remain. They have been recorded by multiple submersibles and probes, from Japan's Kaiko to modern free-fall landers. Whether viewed through cameras or sonar scans, the shapes are too straight, too even, and too purposeful to be caused by water currents. There is another detail that makes these observations harder to explain. On several dives, short-range sonar detected moving objects beneath the submersibles. In one mission, the equipment received a clear echo from something more than 7 meters long moving quickly in the darkness at a depth of over 8,000 meters. Both the speed and the size exceed what any known animal could survive under such extreme pressure. Official reports labeled the echo as sonar noise, but the crew members who reviewed the data insisted it looked far more structured than typical equipment interference. No one is eager to claim that a giant creature is responsible. One possible explanation is movement within the seafloor itself. At these depths, the soft mud can shift in smooth, unusual ways, creating shapes that resemble drag marks. But there is a problem. The tracks often appear alone. They begin abruptly and end just as suddenly instead of following slopes or spreading out like normal geological shifts. So what are they? Are they a type of seafloor movement that science has not yet understood? Or are they traces of a form of life that has never been seen directly? No one can answer with certainty. What is clear is that meter-wide, 100-meter-long tracks lying silently beneath a darkness deeper than Everest's height will continue to raise questions for years to come. They do not fit biological models, nor do they fully match geological ones. They simply exist, and they are larger than anything humanity has ever identified in the deepest part of the Earth. And it is this mismatch, this inability to fit into any familiar category, that makes the Hadal zone so unsettling. Light that does not belong to living creatures. The massive tracks on the seafloor are only one part of the mystery. There are phenomena even stranger, because they leave no marks, no scratches on metal, and no physical traces at all. They appear suddenly, vanish instantly, and show up only on camera. These signals do not look like movement or the glow of a living organism. They are flashes of light, light appearing in a place where light should not exist. In the deep ocean, light itself is not unusual. Many creatures produce their own glow through chemical reactions, a process known as bioluminescence. Below 1,000 meters, the ocean is in permanent darkness, and faint blue dots of light are common. Some are signals, some are lures, some are warnings. But when submersibles descend past 10,600 meters, far beyond the depth at which any known organism can still emit light, cameras have recorded something completely different. Bright flashes appear out of the darkness, intense enough to resemble tiny underwater explosions. In some footage, an entire patch of water lights up and fades in an instant, like the brief burst of a camera flash at the bottom of the sea. This makes little sense. Bioluminescence produces small, steady glows, not wide, powerful bursts. And at these depths, known forms of life are too fragile, too slow, and too limited to create anything close to what the cameras captured. Nothing about these flashes matches the patterns of biological light. Some researchers believe that under the enormous pressure of the Hadal zone, water and other fluids may behave in ways that do not occur near the surface. A tiny pressure shift might force tightly compressed water to release energy suddenly, creating a brief pulse of light. It would be like a microscopic bubble collapsing from extreme compression. But here it happens more than 10 kilometers below the surface, where the pressure is strong enough to flatten steel. Another possible explanation lies beneath the seafloor. The deepest trenches sit along the boundaries of Earth's shifting crust. When rocks are squeezed or experience tiny fractures under immense pressure, they can release sudden flashes of light, a phenomenon known on land as earthquake lights. In the deep ocean, where no human eye can witness such events directly, only the cameras on submersibles can capture these moments. What is even more intriguing is that each time these strange flashes appear, the accompanying data shows a small anomaly. Sometimes it is a sudden pressure spike, sometimes a faint vibration in the mud, and other times a temperature change that happens far too quickly to fit the usual patterns. None of these clues provide a final answer, but together, they hint at pulses of energy rising from the deep in ways current scientific models cannot yet predict. Sounds unlike anything else on Earth. The strange flashes of light in the Hadal zone are already enough to puzzle scientists. But at these depths, there is something even more unsettling. There are sounds. And it is these sounds that trouble research teams the most, because some of them do not resemble anything naturally recorded on Earth. To listen to the seafloor, scientists use special underwater microphones known as hydrophones. Under normal conditions, these devices capture whale calls, tiny cracks in the seabed, or the rumble of strong currents striking the trench walls. Yet in the deepest region, the hydrophones pick up something entirely different: long echoes, metallic scraping noises, sharp whistles, and vibrations that feel as if a massive object is being dragged beneath the mud. Some recordings even resemble the steady rhythm of a machine, despite the fact that no submersible or vessel was anywhere near the area. One researcher described a recording as sounding like something very large scraping against the ocean floor, but no one knows what that something could be. In another case, a short recording captured a deep, resonating exhale, as if a breath was coming from a hollow space in the dark. The tone did not match any known animal, nor did it resemble shifting rock. It came quite literally from a place where nothing ordinary should exist. What makes the situation even more confusing is that these sounds do not follow any clear pattern. Some days, the hydrophones remain completely silent. On other days, they capture dozens of quick tremors, almost like the seafloor itself is flexing with its own rhythm. A few sounds appear so quickly that they cannot be classified at all, as if they originate in a medium where sound travels differently from the world above. Of course, not every noise comes from a living creature. Many of them are likely caused by tiny movements in the subduction zones, of course, where tectonic plates slide beneath the crust. At such depths, even a small shift within the Earth can create a noise that the hydrophones interpret as something large moving through the dark. But separating the sounds of the ground, the water, and an unknown source is incredibly difficult. What is clear is that these recordings do not match existing models. Some echoes are too steady to be natural, others are too sharp or too organized to come from random compression inside the mud, and there are high-pitched whistles that remain unexplained even after repeated analysis. These strange sounds suggest that the deep ocean is not a silent, still world. It is a place with movement, tension, and interactions that human technology is only beginning to detect. And just like the mysterious flashes from the previous chapter, the sounds form another piece of a puzzle that hints at a world operating under principles science has not yet understood. When the deep ocean breathes energy from inside the Earth, beneath the soft mud of the Hadal zone lies the Earth's crust, a place that is constantly shifting even if the movement is too slow for humans to sense. But the instruments feel it clearly. They record small changes in temperature, short bursts of vibration lasting only a few seconds, and sudden pressure spikes that resemble a pulse of hot energy rising from beneath the seafloor. One of the most powerful forces down here comes from hydrothermal vents. These are cracks where seawater is pulled deep into the crust, heated by the rock below, and then forced back out. In the normal deep ocean, the water released from these vents is already extremely hot. But near the Hadal zone, some vents can exceed 450 degrees Celsius. And the only reason the water does not boil is because the surrounding pressure is unimaginably high. There is more than just superheated water. At the underwater volcano of Daikoku, researchers have discovered something that should not exist at the bottom of the ocean. A lake of molten sulfur. Thick, black, bubbling like a cauldron of toxic liquid, and nearly 200 degrees Celsius, it is hot enough to destroy or dissolve any equipment that strays too close. The scene looks less like Earth and more like another planet. The deep ocean does not always erupt with dramatic force. Sometimes it breathes in smaller, stranger ways. Temperature sensors have recorded sudden spikes of 30 degrees Celsius or more within only a few seconds, before returning to freezing conditions. These jumps happen far too fast for any normal surface process. They may be brief surges of heat pushed upward from the Earth's interior, like a burst of energy escaping before fading again. Often, these pulses appear near the same moments as the mysterious lights from Chapter 4 or the unusual sounds from Chapter 5. They are not strong enough to form a clear pattern, but they are consistent enough to show that the deep ocean floor is not still. It is a place where energy from deep within the Earth rises constantly, sometimes quietly, sometimes forcefully, creating disturbances that current scientific models cannot fully explain. All of this happens in complete darkness beneath more than 10 kilometers of water. Humans cannot witness it directly. Everything depends on brief numbers blinking on a screen, and every strange number is a reminder that the Hadal zone is influenced not just by the ocean, but also by the restless forces beneath the planet's crust. If the lights and sounds suggest strange signals from the deep, then these pulses of energy show that the deepest trenches are shaped by both the ocean and the Earth itself. This overlap makes the Hadal zone one of the most unpredictable places on the entire planet, the physical evidence that defies explanation. The pulses of heat and pressure rising from the seafloor already tell us that the Hadal zone is far from quiet. But what troubles researchers even more are the things they can hold in their hands. These are not numbers on a graph or distorted signals on a monitor. They are marks left directly on the equipment that humans send into the deep, marks impossible to mistake for noise or malfunction. This is physical evidence, clear and undeniable, showing that something at the bottom of the ocean is operating outside the rules science currently understands. Deep-sea probes are built from some of the strongest materials humans can manufacture, including titanium and high-pressure ceramics. They are designed to survive more than 16,000 pounds of pressure for every square inch, a force strong enough to crush most metals on Earth. Yet on several missions, when these machines were hauled back to the surface, the research teams found scratches carved deep into the metal. And in some cases, the equipment was bent in ways no one could explain. One submersible returned with a long gouge running across its titanium frame, almost as if something hard and powerful had dragged itself along the hull. The strange part is that the bottom of the trench is covered in soft mud, not sharp rocks or coral, and every moment of the descent and ascent had been tracked to avoid any contact with the trench walls. And it is not only scratches. Some equipment has vanished entirely. In one mission, a metal bait cage lowered to more than 8,000 meters went silent after just 30 minutes. When another vehicle was sent down to investigate, the team found nothing except a smooth, circular depression in the mud. There was no metal frame, no cables, no fragments. It looked as if the entire structure had been crushed flat or dissolved, then erased without a trace. The final data from the device showed nothing unusual except for a brief fluctuation in pressure lasting only a few seconds. Other evidence lies directly on the seafloor. There are massive grooves carved into the mud, almost a meter wide and stretching for hundreds of meters, as if something enormous had dragged its body across the bottom. These marks start suddenly and end just as abruptly. They do not resemble the trails made by equipment or cables, and the largest known animals at these depths, the so-called deep-sea giants, like crustaceans around 30 centimeters long or the palm-sized single-celled organisms, are far too small and too light to create such tracks. Their bodies simply do not match the scale of these silent runways beneath the mud. Some researchers suggest the grooves might be created by unusual movements in the seafloor under extreme pressure. The mud could compress and slide in a single direction, leaving long, smooth streaks that look like drag marks. But many of these grooves are too symmetrical and too consistent in depth, stretching tens of meters while maintaining the same width from start to finish. Something that is hard to explain with mud shifting by itself. All of this, the warped equipment, the missing metal, the giant tracks along the seafloor, comes from different missions in different trenches around the world. None of the incidents are identical, but they share one thing in common. They do not fit the scientific models used to describe the Hadal zone. Official explanations often fall back on collisions, mudslides, or equipment failure, but when these small details are put together, they form a larger picture. The Hadal zone may be influenced by forces we do not yet understand. If the lights are signals, the sounds are echoes, and the pulses from the seafloor are signs of hidden energy, then the scratches, the warped metal, and the vast gouges in the mud are physical proof. Something humans can touch and see, that the deepest ocean is operating on a logic we have not yet cracked. What science is quietly avoiding? After years of study, scientists agree on one thing. The Hadal zone does not behave like any other environment on Earth. It may follow natural rules that science does not yet have the language to describe. There is no single hypothesis that explains everything happening down there. Not the sudden flashes of light, not the strange sounds, not the shifting pulses of heat, not the vanished equipment, or the tracks carved into the mud. And this is precisely what makes researchers uneasy. Because if nothing fits neatly into one explanation, then the only conclusion left is that the deepest part of the ocean, deeper than the height of Mount Everest, might represent a different version of Earth where matter, energy, and even life follow a logic we have only glimpsed through a few scratches on metal, a flash caught on camera, and lines of data jumping wildly on a screen. In science, silence is not always a lack of information. Sometimes it is the result of information that is too unusual, too disruptive, too far outside accepted models to present without raising a larger question. If the Hadal zone does not follow the rules we use to describe our planet, then how well do we truly understand the Earth? And perhaps this is what science is actually avoiding. Not the fear of a giant creature hiding in the dark, but the fear of admitting that right beneath our feet exists a place where our knowledge is not enough. A region so deep, so isolated, and so unfamiliar that it may as well be another world living inside our own.